Just comment also that one of the things that I find surprising is that we do look at all these events as sort of a single thing, or single occurrences, or one cause of mortality, and that Kristi's work came out after we had really looked at the oceanographic conditions in the spring of 2007. There's no question that it was the thinnest mixing layer ever recorded in the strait. And if you think about winter 2006 in the spring, that was the damage in Stanley Park. We had very unusual high winds all spring. We had the lowest amount of sunlight in the spring. And when you really look at then an abnormal flow, we came within inches of a flood in the Fraser. So all that water is pouring out in the strait. And so the mixing layer was under half a meter. So really, you might have had stressed fish coming out. The stress might make the animals more, well, partially stressed. They get into an environment where they're not growing, they're under some condition, other things are chasing them around. It could have been that somebody described it a perfect storm for sockeye salmon. Or maybe it was a one-time event, and it only happened once in the last century that we know of. But the fact that they had such different profiles between years is fascinating.
Having actually ran the salmon site for a number of years too, having been involved in animal husbandry most of my life, stress is very often related to disease and shellfish actually in the stock and in the salmon. So it's definitely
one kind of complication I should mention with sort of equating levels or abundance of pathogens with poor conditions is some work that's come out of Oregon and Kim Jacobson's lab, where they've been looking at BKD, which is a bacterial infection, and parasite intensity and load in about 12 years of data, where they've been sampling Chinook salmon and Pogo salmon from the Columbia River, and so they're monitoring this, these pathogens once these fish have already been in the ocean for about a month and a half. They don't have any data from the river, so they don't have any data where they can look at shifts in prevalence. But one of the things that they found in most of the years of their studies is that a month and a half into the ocean, they can't find fish that carry high loads of BKD or high-intensity parasite infections in years where ocean conditions are poor. They're already gone. And so your sampling you have to make sure that with your sampling that you're able to look for shifts in prevalence in order to pick up that kind of data. Because one would first go, well, what does that mean? Why are we not finding any pathogens, and pathogens are associated with good years? Well, it's probably because you're past the sample point when those fish just would have perished in a stressful environment.
I just wanted to follow up with what you were describing, Brian, what was going on in 2006 and 2007 related to Fraser. Because most of the declines in productivity are pretty common, from Washington and Oregon all the way up to Southeast Alaska, so it's a fairly large scale. I don't recall what happened in 2009, whether that was just mortality event specific to the Fraser, or whether that was coastwide.
Yeah, there are common events. And Randall Peterman has published, and students have published on this widely. But you really start looking at areas through the south. Barkley Sound was very productive. It has not followed the trend in the Fraser River. And there's even stocks in the Fraser River. Kristi only brought up the Harrison, but the most famous is probably the Lake Run Adams in Shuswap Lake, and it has not shown a decline. It's not shown an increase in productivity. All right, so there's a stock within the Fraser that bucks the trend, and there are other lakes through the system. The covariance between the different stocks is modest. It's around 30–40%. Right, so we still got a lot of specific variation going on. It's interesting that the covariation between the Fraser stocks, and we talked about Fraser sockeye, but there's actually, what did they decide on now, 38 CUs or conservation units? 38 different populations that do their own thing. Right? The covariance amongst those, where we've actually got good records going back to 1948, is only about 30%. So there's still a lot of independent variation going on that is difficult to explain. Now, before we finish, I was just going to ask one quick thing on the shellfish, because we kind of left Helen out here. And one of the points that you brought up related to climate change, and I had a paper put on my desk today that talked about the partial pressure of CO2 in water and the effect on behavior of fish, which I found to be fascinating. Not something that I have thought about yet, but I'm really concerned about what could be going on with intertidal zones, and particularly things like shellfish you talked about today and climate change. Do you see a role for setting up monitoring programs like that through the new Shellfish Center?
Well, there is actually, I'm Kristi's husband actually, through Island Scallops, is doing some monitoring there. And then we're going to be doing more monitoring actually from the place where I work, probably up in the Deep Bay. But nothing's actually been set up as a formal monitoring program. I think there's been, considering that 50% of the shellfish aquaculture industry is in that direct area, I think it would have a lot of, provide a lot of useful information for the farmers. But at this point, it's finding funding to, support those programs, and those programs should be long-term programs. They are seeing massive changes in pH, even within, I suppose, in a few hours. I mean, Gurney can talk more about that, because they've been seeing that down in Washington State for a number of years now.
We actually have a constant monitoring program in our hatchery, monitoring for conditions, including PCO2. And we measure it both in intake pipes and in the out in the bay. And so we have probes down 365 days of the year. And that was spurred by some stuff that happened down off the Oregon coast, and also a couple of very poor years in our hatchery where we had very low survival, which we're trying to elucidate why that was happening. Still not that clear, but they have been doing a lot of analysis, and to a certain degree they are seeing some correlation between pH. And actually, in 2010, I actually lost probably 25-30% of my production on the mussel farm due to a event where we had a dry time crash, followed by going from a high pH in the bay to a low pH, and then a very persistent dinoflagellate bloom, which lasted for 10 weeks, which it turned out that the mussels were not eating, they started to do. So yeah, but yes, including some of Helen's work is the next step, because that's a very sensitive tool that you could use within the hatchery, on RV within the hatchery to see if stresses were affecting the larvae.
Well, I have 5 o'clock. So I guess we're due to tie up. Brad, you got the last word?